Hi, I'm Thomas. Welcome back. Our topic is integration. This is volume example 3. Our requirement reads, find the volume obtained when the region bounded by y equals 1 and 2x squared plus y squared equals 9 is rotated 360 degrees about the x-axis. I've copied the functions from Desmos into the upper right corner of the screen, so we'll use that as our diagram. We want to identify, to begin, what area is it that we're working with. So the region bounded by these two functions is what is above y equals 1 and what is under the curve 2x squared plus y squared equals 9. Notice in this example that our rotation is about the x-axis. That means that we're going to be using the integration rule with respect to x. Notice also that we're not on the axis. We're rotating a region whose lower boundary is y equals 1. So in our calculation, what we want to do is subtract out an empty space that will be in our volume calculation. That empty space, thinking about y equals 1, has a vertical distance from the function to the x-axis of 1. So the height of this extra space is 1. And the length of this extra space is determined based on the two solutions for the functions that were given. You can do algebra to find these solutions. I'm going to go ahead and write them in. Our points of intersection are x equals negative 2 and x equals positive 2. From negative 2 to positive 2 is a distance of 4. So this extra shape has a height of 1 and a length of 4. Try to visualize the shape of the rotation of that open area. It's going to be a cylinder that has a radius of 1 and a length of 4. We'll calculate the volume of that cylinder and subtract that volume from the total volume that we calculate with our integration rule. Let's go to the algorithm to work the integration. Step 1, identify function type. I see in this scenario the function I'm working with is the boundary of a volume of revolution. So I'm working with a function relating to a volume calculation. Therefore, I need to use one of the two volume integration rules. We've identified that we're dealing with the x-axis for revolution, so we'll use the with respect to x integration rule. Step 2, apply the rule. Volume equals pi times the integral of, our interval is negative 2 to 2. Those are the two intersections of the functions that we're working with. The function which is the upper boundary is 2x squared plus y squared equals 9. We want to set that so that it is a function with respect to x. I'll use algebra to get to 9 squared equals 9 minus 2x squared. Now from here, I'm not going to further simplify. I'm not going to calculate y. The reason for that is because y squared is the x function squared. And that's the input that I want into the integration rule. Instead of inputting the x function and then squaring it, I'll simply take what I have, which is the x function squared. So the x function squared is 9 minus 2x squared with respect to x. And I want to remember that I will be subtracting volume of my cylinder. Now I'll work through the integration. Volume equals pi of the quantity. I'll integrate each of the terms. 9 becomes 9x. Minus 2x squared becomes 2 over 3 x to the power of 3. On the interval of negative 2 to 2, minus the volume of the cylinder. Notice that the volume of the cylinder isn't being integrated. That's outside of the integration. Continuing, we have pi times 9x will be 9 times 2. Minus 2/3 x cubed will be 2/3 times 2 cubed. Subtracting both terms with an input now of negative 2. 9 times negative 2 minus 2 over 3 times negative 2 cubed, all multiplied by pi, minus volume of cylinder. Note that we're not using step 3, include constant of integration, as this is a definite integral. Volume equals pi times the quantity, 9 times 2 is 18, minus 2/3 times 2 cubed is 2/3 times 8, which is 16 over 3, minus the first term of 9 times negative 2 is negative 18, distributing the negative sign, minus negative 18 will be plus 18. The next term is minus 2/3 times negative 2 cubed. Important note, I need to go up to the prior line and add in brackets for the negative 2, so that we are cubing negative 2. As I had it written, we'd cube 2, then multiply by negative 1. So an important correction here. We're cubing negative 2. Calculating this term, negative 2 cubed is negative 8, times negative 2 over 3 is positive 16 over 3. Distributing the negative is minus 16 over 3. All multiplied by pi. And now I'll go ahead and input the numbers to calculate the volume of the cylinder. Volume of cylinder is pi radius squared times height. I'll write that in. Looking at our cylinder, the diagram shows a radius of 1 and a height of 4. The cylinder's on its side, but that 4 is height. So we will subtract pi times 1 squared times 4. Let me make a note a couple of lines back for the algorithm. Step 5, the calculation of the definite integral value. We've input at that point our integration limits to calculate our volume. And now continuing on to our simplification, volume equals the quantity times pi sums to 76 over 3 in the first term. The second term, pi times 1 squared times 4, is 4 pi, and 76 over 3 pi minus 4 pi equals 64 over 3 pi. This is a three-dimensional figure, units cubed. So the volume obtained when the region given is rotated 360 degrees about the x-axis is 64 over 3 pi units cubed. We've completed our requirements, and this concludes volume example 3.